In section 1.2, we've got some more vocabulary words to cover. Qualitative variables are variables that can be separated into different categories. Sometimes these are called categorical variables to indicate the categories. Some examples: different types of colors. If you were looking at the variable of color, that would be a qualitative variable because you would have red, blue, yellow, green, purple, brown, black, etc. Another example of a qualitative variable, we could look at flavors of ice cream. Those are categories. So asking someone what their favorite ice cream flavor is, we would be collecting a categorical or a qualitative variable. Quantitative variable, pointing out that first part, quantity. Quantity means number. So a quantitative variable are numbers that'll represent counts or measures. So one example of a quantitative variable could be height. Another could be something like miles walked. Height is a measurement, so it is a quantitative variable. Miles walked could also be a measurement. We could consider something like the number of classes. That would be a count. These are all examples of quantitative variables. Within the quantitative variables, we can break the quantitative variables into two more categories. We can talk about discrete variables. Discrete variables are quantitative variables that represent counts. So I'm counting something. We use whole numbers here. Whole numbers 0, 1, 2, 3, and so on. An example of a discrete variable could be the number of eggs that a hen lays. Whether that hen lays a small egg or a large egg, a single yolk or a double yolk, it's still an egg. So we can count the number of eggs that a hen lays. That's a discrete variable. A continuous variable is a quantitative variable that assumes values corresponding to an infinite continuous scale. And this is obtained from measuring. So remember that quantitative variables are numbers that represent counts or measures. The counts are discrete variables. The measures are continuous variables. This infinite continuous scale that continuous variables can assume, we're talking about a real number line. A real number line has decimals, fractions, whole numbers, irrational numbers. All of these are values that continuous variables can take on. And remember that continuous variables are obtained from measuring. An example for a continuous variable would be the amount of milk a cow produces. A cow could produce a whole gallon. She could produce 1.43 gallons, or any number from 0 to whatever in theory, but we are measuring the amount of milk. We can't count the amount of milk. We can only measure it. And so that would be a continuous variable. And just like before, we're going to take all of these vocabulary words and apply them in the different situations that come up. A boundary is the range of values that would round to a given number. Let's look at a rounding reminder. If I had the number 7.42 and I wanted to round it to the nearest tenth, or we could say 1 decimal place, then I'm looking at the 4. Whatever's to the left doesn't matter, but I want it to end 1 decimal to the right. That's what to the 10th means, or to 1 decimal place. One more decimal place, one place after the decimal. So with the 4, I look directly to the right, and I see that I have a 2 there. So we can actually think about this like a hill. And what happens is on this hill, we have 7.4 and 7.5, for example. So looking at these two specific numbers, so 7.4 coming from the first 2 digits there, and 7.5. So where is the 2 on my hill? The 2 is here. Imagine this like a little car. If my brakes stall, the car is going to roll back down the hill and become 7.4. So for this number, 7.42, it would round to 7.4. 2 is less than 5. See, 5's in the middle. The 7.42 is closer to 7.4 than it is to 7.5. And that's the idea with rounding. We want to choose the number that's closer to the given number that we have. Okay, looking at a different example, 7.46. We're going to do the same thing, round to the nearest tenth. We take a look at the 4 and we go immediately to the right. I see a 6. 7.46. I'm going to draw my little car again. This time if my brakes stall, they're going to go forward to the 7.5 number. So 7.46 would round to 7.5. So we look at the number directly to the right and we determine, is that number less than 5, or is that number greater than or equal to 5? If the number is less than 5, then we're going to keep the digit as it is and just drop off that place. But if the number is greater than or equal to 5, we take that tenths place that we're rounding to and we bump it up. And here in the middle, we naturally just round 5 up instead of keeping it because it's exactly halfway between. So we round it up. Okay, what does that have to do with boundaries? It has to do with boundaries in that if I look at this number 7.4, what are the numbers that would round to 7.4? Well, 7.4 would have all the numbers from 7.35 up to 7.45, but not including the 4.5. The 4.5 is exactly in the middle where it breaks. So we would look at this if we're using some interval notation. We would look at the boundary for 7.4 as 7.35 to 7.45, but we're not including 7.45. So all of the numbers that fall between 7.35 and 7.45 would round to 7.4. And that's what we mean by boundary. This is going to become very important in Chapter 2 when we start creating graphs on data. We're going to have to come back and talk about boundaries. All right. The last 4 definitions for this section have to do with something called levels of measurement. There are 4 levels of measurement. And just as it means, there are levels. We have the first level, nominal. The next level up is ordinal. The third level up is interval. And the last level, the highest level, is ratio. With nominal level of measurement, the only thing we can do is put the variables into categories. So for the nominal level, we have mutually exclusive categories. And there's no order to them. An example would be like the ice cream, or maybe hair color. We can put it into mutually exclusive categories, but we cannot order them in a way that's standard. Ordinal level does give us an ordering. So we still have mutually exclusive categories. Remember, these are levels, so whatever happened before, we inherit that property with the next level. So ordinal level, we still have mutually exclusive categories, but this time they can be ordered. This one could be something like ranking a restaurant, like bad, okay, and good. We have mutually exclusive categories, and we can order them worst to best, for example. Nominal and ordinal levels of measurement refer to those categorical or quantitative variables. Categorical variables will fall into nominal and ordinal levels of measurement. Interval level of measurement, we still have those mutually exclusive categories with order, and precise differences between measurements exist, but there's no true zero. Okay, so what do we mean by this? Well, one example is if we're looking at the year numberings, like 2021. We can talk about years like 1984 and 1938. We can go farther back to 1572 or 1066. We can go even farther than back and talk about 3000 BC. But what doesn't happen is a year zero. When we talk about years, we go from 1 before the Common Era to 1 in the Common Era. There's no year zero. This is an example of no true zero. Another thing that we can say is the year 2020 is not twice as long as the year 1010. That doesn't make sense when we're talking about years like that. Another example of interval level of measurement that we'll talk about is temperature. This one's a little tricky because temperature does have a zero on it, but the zero in the Celsius and the Fahrenheit measurements don't mean no temperature. And so that zero isn't a true zero in the sense that saying the temperature of 80 degrees is twice as hot as the temperature 40 degrees. That's not true. The measurement as far as ratios go doesn't make sense. And so temperature is another example that doesn't have a true zero. The only exception to this, for those of you who've had chemistry, biology, other science classes, and you've learned about Kelvin, you could say the absolute zero of Kelvin could be the, quote, true zero. And Kelvin might push you into ratio, but that's questionable, and it's something that we don't have to worry about in our class right now. And then the last one is ratio. Ratio has all of the other characteristics. Mutually exclusive categories with order and differences, and there is a true zero. Example could be height, weight, the amount of milk for a cow, the amount of eggs for a hen. We can say for a hen, 4 eggs is twice as many as 2 eggs. Or 9 gallons of milk is 3 times 3 gallons of milk. So we have this idea of multiplication that makes sense for ratio level. So here, for interval and ratio, these are dealing with the quantitative variables, the variables that can assume numbers. And in the next part of our lesson, we'll go through and apply these definitions.